So today let us see what is about discrete mathematics. So discrete mathematics by the word itself means that it is discrete, which is not connected. And before we enter into this discrete mathematics, let us see who all will be the target audience of this discrete mathematics. So the target audience will be students of information technology and computer science engineering. So the main branch of study will be of students of IT and computer science and engineering. And next is students who want to learn competitive programming. So whoever is willing to go for competitive programming, definitely they need this course discrete mathematics. And finally, the students who are appearing for GATE and other competitive exams, they also need this discrete mathematics. So which means that this discrete mathematics, it is a very, very important tool for the students who want to appear for the GATE as well for the other competitive examinations, and also the students who would like to get their BTech graduate degree and BE graduate degree in the field of information technology and computer science engineering respectively will definitely undergo the course discrete mathematics. So before we enter into others, we'll see why this is very important, this course, and what is meant by this discrete mathematics. So we'll know what is all about this and then we'll enter into it. First, let me tell you why study discrete mathematics. So the first and foremost point is that it develops our mathematical thinking. So mathematical thinking will be developed by means of this course. And the second point is that it improves our problem solving ability. So here we will be studying many tricks in this particular course in order to appear for the competitive exams as well as for the GATE, and the students who are undergoing the digital electronics, definitely there will be many shortcut keys and the tricks. So from that you can improve your own problem solving ability. And the third point is that it will be useful in compiler design, databases, computer security, operating systems and automata theory. So definitely this discrete mathematics will be very important branch in the study of compiler design, databases, computer security, operating systems and automata theory. And now I said about why we want to study this discrete mathematics. It is useful in all these categories. And next is what is all about discrete mathematics. So in short, we can tell that discrete mathematics, it is a branch of mathematics that involves discrete elements or discrete objects that uses algebra and arithmetic. And also it is a very important tool for reasoning as well for problem solving capabilities. So that is why discrete mathematics. So discrete mathematics, it is a branch of mathematics, involves discrete elements or objects that uses algebra and arithmetics. And also it is a very important tool for reasoning and problem solving capability. So as I've said that discrete mathematics means discrete, it means not connected. Now let us see, if it is not connected, definitely it should be a continuous one, right? So now we'll distinguish what is the difference between the discrete object and the continuous object. So discrete object, very obvious, we can say that one of a very good example in day-to-day life we make use is digital clock. So in the digital clock, each and every minute, seconds, it will be sharply denoted. So it is an example of discrete object or discrete element. Whereas in case of a continuous element or continuous object, we have a very good example, since because majority of the students will be all engineering graduates. So a very good example we have as analog clock. So in the analog clock, we'll have the continuous, that is, which means the hour hand, minute hand, second hand, everything will move smoothly over the time. So that is an example of continuous element or continuous object. So let us see a mathematical oriented example for discrete and continuous one. So in case of the discrete, I can say that suppose in case if I ask you to draw a graph for the line y is equal to x, where x belongs to the natural number. See, now look at your first thing is natural numbers are discrete. So while I'll be explaining why this is discrete. Suppose if I ask you to draw a graph y is equal to x for x belonging to natural number. So obviously if x belongs to a natural number, then y also will belong to the natural number. So now from this we have x-axis here in the horizontal line and we have y-axis in the vertical line. So now if I ask you to draw the curve as y is equal to x, how do we draw it? So now if I give x as 1, my y will also be equal to 1. If my x is 2, y also will be equal to 2, and so on. So now I'll have to plot these points into my graph. So I have 1, 2, 3, 4, so on. I have here 1, 2, 3, 4, so on. So this is 1, 1. So 1, 1 will be this point. And then 2, 2 will be this point. 3, 3 will be this point. 4, 4 will be this point. So in between 1 and 2, I don't find any value here. So which means that it is discrete. Then in between 2, 2 and 3, 3, I don't find any value here, since because x belongs to set of all natural numbers, I don't have any value. So therefore, if I see this graph, I have 1, 1. Next to 1, 1, I'll have immediately 2, 2. In between 1, 1 and 2, 2, I'll not have any values. Likewise for the rest of the numbers also. So that is why natural numbers are discrete in nature. So next let us see this simultaneous example of a continuous object here. I can say real numbers are continuous. Let me explain you how the real numbers are an example of continuous thing. Again the same thing, if I ask you to draw the graph for y is equal to x, where x belongs to real number. So real number in the sense, we'll start with 0, 0.001, 0.0001 and so on, it keeps going till infinity. So now if I give the value of x as 0, I'll also get y as 0. So this point will be there. And next if I give the value of x as 0.001, I'll have y also as the same value. So next, whatever value I give immediately for my x, I'll be able to get my y. So if next to 0, 0, I'll have the next immediate point, and to that I'll have the next immediate point. So on, it keeps continuously raising. So that is an example of a continuous object. And as I said earlier, the another example of a discrete object, very good example, we can say that digital clock is discrete in nature. So which means that here each and every element, that is the hours, minutes and seconds, it will be sharply displayed in the clock. So that will be an example of a discrete object. And next is analog clock. So in our analog clock, definite hour, minute and second hands move smoothly over the time. So therefore, it is continuous in nature. So this is the difference between the discrete and the continuous object. So first of all, before we enter into the discrete mathematics course, one should be able to distinguish between what is the discrete object and what is the continuous object. So this is the main difference, and this is a very good example I've given here. So before you enter into this, one should be able to identify whether a given element is discrete or continuous, and accordingly we will have to give the examples for each and everything. So next, after that, we will see what are all the contents we will be covering under this course, Discrete Mathematics. So the first unit we will be seeing Propositional Calculus. Second is Predicate Calculus. Third one, it is Set Theory. Fourth one, it is Relation. Fifth one, it is Functions. Sixth one, Partial Order and Lattices. Seventh one, we will see Permutations and Combinations. So these are all the chapters we will be discussing under this course, Discrete Mathematics. So the reference books what I am referring here throughout my session or throughout my course, it will be Kenneth H. Rosen, Discrete Mathematics and its Applications with Combinatorics and Graph Theory. Next is Grimaldi, Discrete and Combinatorial Mathematics and Applied Introduction. Third book, it is CLU, Elements of Discrete Mathematics. Of course, we also have many more reference books. We can have Tremblay and Manogar, Allendore, Venkatraman. So all these are very good books which one can refer for the entire course Discrete Mathematics. And towards each and every unit, at the end, I'll be discussing you all the possible gate questions and also the few of the previous year gate question papers. Those topics I'll be discussing. So the final point is gate questions will be discussed at the end of each and every unit. So this is what my plan, and we'll be going according to this plan. So now according to the plan, the first content it is propositional calculus. So I'll have to explain what is propositional calculus, and even before going into propositional calculus, we have logic. So that logic, it will be divided broadly into two categories. One is propositional calculus, the other one is predicate calculus. So what is all about this logic first, and then we'll see what is propositional calculus and what is predicate calculus. So logic, what is meant by logic? Yes, so logic, it is method of reasoning. So method of reasoning is nothing else but logic. And logic also, it rectifies the correctness or the errors in the program. So because most of us are in the engineering field, definitely this logic will help us to rectify the error in the programs. So mainly logic is nothing else but method of reasoning. This is a very good tool to evaluate our reasoning ability. And next is, after knowing what is logic, we have broadly classified that into two categories. One, it is called as propositional calculus, the other one, it is predicate calculus. So now what is all about this propositional calculus? That we will be dealing in unit 1. So propositional calculus. So calculus we all know, normally that from the school days we would have studied it. So we just leave off this and we will see what is this proposition. So once if we are able to derive the meaning for the word proposition, then propositional calculus becomes very easy for us. So now what is proposition? And this proposition also, you might have studied that in school in grammar parts. So can I have an example of a proposition before entering into what is proposition? So you all can just give me an example for proposition. Okay. So it's not an issue. We'll just discuss about what is a proposition. So proposition, it is any declarative statement that takes either a truth value or as f or as a truth value t. Right? So now we'll see logic. I have said that it is method of reasoning. Method of reasoning. This logic, it is divided into two categories. One is called as propositional calculus and the other one is predicate calculus. So propositional calculus right now we will deal, and predicate calculus we will see in the second session. So propositional calculus, so what is proposition? So now proposition means it is a declarative statement or sentence which has the truth value as t or the truth value as f, but not both simultaneously. But not both simultaneously. And now, since because you might have studied digital electronics in the previous semesters, this truth value t will also be denoted by 1 and the truth value of f will also be denoted by 0. So t is nothing else but it represents true. F, it is false. Right? So now proposition, it is a declarative, any declarative statement or sentence which has either a truth, that is very, very important, which has either the truth value as t or the truth value as false or f, or we denote it by 0, but not both simultaneously. So whenever I give you a statement and if I ask you what's the truth value of that particular statement, either you must have the answer as t or you should have the answer as f. You cannot have the value as t and f together for a statement. So if you cannot have either t value for a statement or you cannot have f value for a statement, then it is not a proposition. Say for example, if I say that sugar is sweet, do you all agree with that? Say yes or no? Yes, everybody will say yes. Even a 2-year baby or 3-year baby, 4-year baby will definitely say after tasting it, yeah, it's sugar only, it is sweet. So therefore, sugar is sweet. That is a very good example, right? Sugar is sweet. That is a very good example of a proposition. Now, if I ask you, sugar is sweet, what's the truth value? The truth value of this is t, you will say, or you will say it to be as 1, or you will say it to be as true, right? Since because this statement has a truth value as t or 1 or true, we call this statement to be an example of a proposition. Now understood what is proposition here clearly? So any declarative statement which has either a truth value as t or a truth value as f, but not both simultaneously. So this is a very good example. So next is, I'll say that is 2 plus 2 is equal to 6. So if I ask you whether 2 plus 2 is equal to 6, what answer you will give me? Yes, very good. You will say it as no. Everybody will be knowing. Even a 3rd standard, 4th standard student will be knowing that 2 plus 2 is equal to 4 only and it is not equal to 6. So you will say the truth value to be as f here. So whatever may be the truth value, either it is t or f, still that statement is said to be a proposition, right? So if I ask you, how are you? How are you? Right? So now what answer you will give? Will you say the truth value as t or false to this particular statement? No, you will say, how are you? I am fine. So somebody will say I am fine, somebody will be saying that I am fine but not okay, but somebody will be saying that I am okay now but not previously. So you may get number of answers for these kind of questions. So therefore this is not a proposition. This is not a proposition. Suppose if I ask you, give you a statement, sit here, sit here. So what is the truth value? Will you be able to assign a truth value for this? No, my thing is sit here, which means that it is a command statement. So command statement. So command statement is also not a proposition. Command statement is also not a proposition. And suppose if I say that, is the temperature below 25 degrees Celsius today? If I say, if I give you the statement as, is the temperature below 25 degrees Celsius today? There are only two possibilities for this question. Either you will say yes or you will say no, which means yes means it is true, no means it is false. So therefore, this statement is called a proposition. As far as today, you can say that the temperature either it is below 25 degrees Celsius or it is above. So the possible answer for this question is only yes or no. You cannot have other answers for this kind of a question. So it is said to be a proposition, right? So now have you all got an idea of what is meant by proposition? I repeat, so a proposition, it is any declarative statement that will have either a truth value as t or it will have a truth value as f, but not both simultaneously. These are some of the examples of proposition. So I have said how are you? It is what? It is a interrogative statement. So interrogative statement. So it will not be a proposition. I'll have many answers to those questions. So whenever that question has many answers and if it does not have yes or no, then it is not a proposition at all. So this is an example of a proposition. Very good example. Likewise, I can say that milk is white. Yes, milk is white. So you will say the truth value to be as t. So which means that it is proposition. Blackboard is black. Blackboard is black. Yes, obviously this is also true. So you will be saying this to be as true. Therefore, it is also a proposition. So likewise, once if you are very much familiar with the word proposition, you can give n number of examples. I hope you will be clear with the word proposition. So proposition is all that's it. So next is, after knowing what is a proposition, next we can see what are the proposition. So proposition, it is broadly classified into two again. One, it is called as atomic proposition. Other one, it is compound proposition. So what is meant by atomic proposition? After knowing proposition, one should be aware of atomic proposition and compound proposition. So atomic proposition is any statement which cannot be further simplified. So that is called as an atomic proposition. So say for example, I can give you an example as Sita studies well. Sita studies well. I cannot further simplify that statement. So therefore, it is called as an atomic proposition. So any statement which cannot be broken down into further simpler statement, it is said to be atomic proposition. Then what is all about compound proposition? So compound proposition is pooling of these atomic propositions, pooling of one or more atomic propositions together, it is called as a compound proposition. Say for example, the same thing I can give, that is Sita studies well and also sings. So now look at the statement now. Sita studies well is one part and she also sings, that is the second part. So therefore, pooling of these two simpler sentences together with the suitable thing, it is called as a compound proposition. So now I hope you would have got an idea of what is atomic proposition and what is compound proposition. And next is, you must be knowing variables. So here variables are also like say for example, I have given you the statement as Sita studies well. So I can denote that to be as P. So P represents Sita studies well. Sita studies well. So this P represents the variable of the entire statement Sita studies well. And I can also have the another variable as Sita sings. Sita also sings. So that I can represent it by some other variable. So variable is nothing else but if we have either an atomic proposition or a compound proposition, for each and every simpler statements there, I can define a term called as variable. And most probably the variables will be denoted in the lower case as P, Q, R, S, so on, or A, B, C, so on, or even we may also have capital letters, nothing wrong with that, but most probably in the entire course of a study we will use the variables to be as P, Q, R, small letters, or lower case as A, B, C, whatever thing you prefer it, you can use it. And now see here now, I have taken it as Sita studies well. So that I have denoted it as P. So hereafter, if I say it as P, it is not a letter alone or alphabet alone P. It represents, as far as this is considered, Sita studies well. And if I say q here, q means that theta also sinks. That is the variable meaning. And after knowing what is a variable, one should be aware of what is meant by argument. So argument, it is the entire bundle. Like say for example, I may have n number of premises, right? So with a conclusion. So now this entire bundle is called as argument. And these will be called as the premises or the statements given in the problem. And this is the conclusion part of the problem, right? So now argument is nothing else. Suppose in case if I give you an argument and if I ask you to check out whether it is valid or not, how do we check it? So this is an entire bundle of argument. So I have P1, P2, so on till Pn. These are called premises. Premises is nothing else but the given atomic proposition. So we know what is an atomic proposition. That is a proposition or a statement which cannot be broken down into simpler statements. So now these are all the premises I have, and with all these premises one should be able to get the conclusion as C. Whatever conclusion is given in the statement, that one should be able to get it from these set of premises. So this entire bundle is called the argument. Now if I ask you to check out whether a given argument is valid or not, how do we check it? So we will be taking all the premises one by one, and then we will be applying a few of the laws, and then if I get the conclusion from the given thing, then I will say this is valid argument. Valid argument. If I am not able to get the given conclusion, the given argument is not a valid argument. I will say it to be as invalid. So understood? So this is how we define an argument, and we will check whether a given argument is a valid argument or an invalid argument. So after this, we should know about the connectives or operators. Connectives or operators. So we have many connectives in digital electronics, but the very basic connectives we have is negation. This is otherwise also denoted by tilde symbol, and this is negation. We have conjunction and, right? So this is conjunction, will be denoted by and symbol. Disjunction, that is or symbol. Disjunction, that is the next connective we have. And next we have conditional, that is forward arrow. This is conditional connective, or it can be said as if and then. If and then. And next we have biconditional connective. So it is double-sided arrow. So or I can say that if and only if, which means both the ways it should be true, right? So these are the few connectives, basic connectives, which we will be seeing in this course. And now here, whenever the hierarchy is given, what hierarchy we will have to follow with these connectives? So the first hierarchy will be given for negation. Second hierarchy will be given for conjunction. Third hierarchy will be given for disjunction. Fourth, it is for both conditional and biconditional. So conditional means if and then. Biconditional means it is if and only if, which means that forward as well as backward, we call it to be as a double-sided arrow. So conditional, it is single-sided arrow. So these are all the things we should be aware of proceeding with the truth table or tautology or contradiction. You must be aware of these connectives. So the hierarchy also I have mentioned here, right?